Hey guys, and welcome back. Let's go ahead and start out by creating a Kubernetes cluster inside of Amazon Web Services. And I'm going to be using the EKSCTL open source utility to accomplish that. So let me fire up a terminal here. And of course, EKSCTL is a cross-platform utility. I just happen to be using it on Windows 11 here. So I'm going to fire up EKSCTL, and we're going to do a create subcommand. We'll do EKSCTL create. Oops, let me try that one more time. EKSCTL create. And then we'll do a create cluster, of course. There's several different types of resources we can create here. We're going to do create cluster. And then I am going to go ahead and specify a couple of options here. One of the options I'm going to specify is the spot option, which will allow me to get a discounted rate on the worker nodes that are joined to my EKS cluster. And then I'm also going to specify the instance types here and set that to something like a T3 medium node, just so I don't get super large nodes provisioned as part of my node pool. So let's go ahead and do EKS create cluster -- spot, and then I'll do instance types equals T3.medium. And then I'm also going to add on the profile here because I have a credentials profile that I would like to use in order to connect to AWS. And this is going to go ahead and spin up a couple of CloudFormation stacks. The first CloudFormation stack that it creates is for the control plane or master nodes in the cluster. And so that's the managed part of the service. And then once the managed EKS cluster comes online, then it will create the managed node group here as well. So let's give this a few minutes to finish deploying, and then we'll come right back. Okay, so now we've got a cluster up and running here, and now what we need to do is play around with some of the different resources that are available that we've talked about in our diagram over here. So for starters, why don't we explore the ReplicaSet as well as the pod specs in a little bit more depth. Let me fire up a browser here and bring that over here, and we'll head out to the Kubernetes documentation over at kubernetes.io. We'll drill into the documentation section here and head down to concepts. And then we're going to take a look at, I think it's under workloads. And then under there, we've got, sure enough, we've got deployment and ReplicaSet and things like that. So let's drill into the ReplicaSets here. And as you can see, the ReplicaSet is basically going to determine how many replicas of pods it should be creating for you. And you can use this to kind of scale your application up and down in on a manual basis by specifying how many pods you want the ReplicaSet to create for you. Now, when you create the ReplicaSet and it deploys those pods, they'll get scheduled onto different nodes by the scheduler component on the master nodes in your cluster. So you don't have to specify exactly which node these pods are going to get created on. So the ReplicaSet is a pretty basic resource. It does have the pod spec embedded right down here where you can specify your containers. You can specify a name for the container within the pod. Since pods can have multiple containers, the name just helps to uniquely identify that particular container in each of those pods. So for example, if you have maybe a PHP Redis front-end application here, and then you have a second container that you define side by side with that runs the FluentD logging agent, then you could give each of those a different name within the pod spec. And then of course you need to specify your image here as well. So that could be a container image that you are pulling from a public registry like Docker Hub or Quay.io, or it could be a private image that you're hosting on something like Amazon Elastic Container Registry, for example, or any other private registry out there. You could use Azure Container Registry, you could use private versions of Docker Hub, you could use private Quay.io, and things like that. So there's a lot of different options you have for hosting those container images. But then what you'll notice here is that above the pod spec, above the template for that pod configuration, you've got the replicas property right up here. And that's what basically indicates to the ReplicaSet how many replicas of your pod definition you would like to deploy out to your cluster. And then of course, once you've defined this API resource inside of a YAML configuration file, you can very easily just deploy that with a simple kubectl apply command. And then the -f operator is short for the -- file name argument, and that's going to allow you to specify the path to your file, which could be an HTTP URI, or it could be just a local file system path. So let's go ahead and try that out and just understand how replica sets work, since this is kind of what the deployment resource is building on top of. So I'm going to fire up a text editor here. I'm just going to be using Microsoft Visual Studio Code, which is an excellent open source and cross-platform editor here. But you're more than welcome to use whatever editor you would like to. If you're comfortable with something else like Atom Editor, feel free to use that. I'm just going to change the language mode here to YAML, and that'll give us syntax highlighting here for our YAML configuration. And then I'll go ahead and just paste in this replica set resource here. Now, the replica set itself can have a name, so we could call this like my web application. And you also have labels, and these are going to be the labels that are applied to our replica set here. And so I'm going to just maybe say app, Trevor app, and then I'll go ahead and remove this tier for front end. And then I'm actually going to need to make sure that I have a label on our pod spec as well as a match label for the replica set, so that it knows how to determine which resources or which pods it needs to control. So I'm going to call this something like my web app, or let's call it app name as the label name, and then we'll call it my web app. And down here, we'll just copy this and bring that down into the pod spec, because the match labels up here at the replica set level and the labels that you're defining on the actual pods do need to match. So just be aware of that. And then down here under containers, instead of using this PHP Redis container, I'm just going to use something else like Nginx container. And the Docker Hub actually has that available out there. So if you go to hub.docker.com and just do a quick search for Nginx, there's a really nice pre-built container image for the Nginx web server. And the nice thing about it is that there's a bunch of historical tags as well. So if you want to run a specific version of it, you can come out here and just find the version that you'd like to run and specify that tag. So I'm going to choose, let's go back a couple versions here just to find something a little bit older. So I'm going to choose 1.18.0 just as an example here. So we'll bring that back into our configuration here, and we'll just specify that as our container version. And then actually, whoops, that needs to actually go down here. So we'll put that under image. And then for the name, I'll just call it web server. And then I could add in a second container down here as well. So just copy that down, and I could add in like a logging container, and I could use just the FluentD latest container. And so that's basically how you can configure multiple containers inside of a single pod spec, anywhere that you have an embedded pod spec, such as in a replica set. So I'm going to go ahead and remove that comment line, and then we'll just save this onto our local file system as, let's say, ReplicaSet.yaml. And then we can go ahead and apply this doing a kubectl. Let me make sure I'm on the right cluster here. So I'm actually going to do a kubectx. And if you don't have kubectx, you can actually install this using your standard package manager as well. This is a really nice utility that allows you to switch different contexts if you're dealing with multiple clusters. And it looks like my cluster Scrumptious Party here is selected. It's kind of hard to tell, but it is a slightly discolored blue there. And then I'm going to take a look at my namespaces. So I'm going to use kubeNS to take a look at my namespaces. And I'm currently using the default namespace, and I'm just going to go ahead and create a namespace to work inside of. So we'll do kubectl, create namespace, and then I'll call it maybe Nginx web app. And then I'll use kubeNS to just change over into that context. We'll do kubeNS and then Nginx web app. And that should just put us into that context, so we don't have to specify the namespace parameter every time that we're calling the kubectl command line utility. So now let's go ahead and just do an apply. We'll do kubectl apply file name, and then we'll do replicaset.yaml. And that should just create a single resource, which is our replica set. And sure enough, there it is. So now if we do a kubectl get all on the current namespace, we should see the replica set itself along with the pods that it is currently in the process of creating. So right now what's happening behind the scenes is that these pods are downloading the container images, or I should say rather the host is downloading the container images for those pods to spin up, so the FluentD and the Nginx 1.18 container images, and then it'll go ahead and create them. So if we do a kubectl, let's say describe pod, and I'll just paste in this pod name actually, just to kind of see where it's at. So sure enough, you can see in the pod logs right here, it pulled Nginx. It also pulled the FluentD container image, and then it started up the entire pod. So this pod should be up and running. It should have an IP address on our cluster VPC, and so that's good to go. And if we just take a look at all of them again, you should see that we have all three in the running state. So sure enough, we've got 1, 2, 3, and each of them, it says 2 out of 2. That's just indicating that 2 containers out of 2 container definitions are in the running state and ready. So that's kind of a health indicator to ensure that the pods in the replica set are healthy. So now at this point, because we have a replica set resource here, it has a desired number of pods as 3. We currently have 3 running in the ready state. And if we wanted to, we could actually scale this up and say, well, I want 10 pods to be running instead. So we simply change replicas to 10. We don't have to change anything else in this configuration here. And we can just do another kubectl apply command, and that will patch the resource. So it'll basically overwrite this replica set resource and update the number of desired replicas. So now if we do a get all again, instead of seeing just 3 pods running, we should see a whole bunch more. And it actually scaled really, really quickly here in just a matter of seconds. And if we wanted to bump that back down to maybe 2, we could just do 2 instead, and then reapply that. And then the Kubernetes master nodes will basically figure out which of those 10 pods to terminate and basically leave us with just 2 of them left. So if we do a get all again, we should see that we only have 2 pods running, and sure enough, here's those 2 pods. So that's kind of what a replica set looks like, and the replica set, again, is the resource that the deployment is actually using under the covers. So keep these concepts in mind, where you've got your pod spec that determines what containers you're running, your labels as well for the pod, and then you've got the match labels here that determine how the replica set determines which pods the replica set is actually managing based on those label key and value pairs. I hope this has been informative for you, and I'd like to thank you for viewing.